In section 8.2 we look at parabolas again, and previously we looked at parabolas in quadratic form, which was f of x equals ax squared plus bx plus c, where a is not equal to 0. And then we also analyzed some special cases that we're going to review here again in this section. So we looked at a few forms like these, and we said in the first one, if a is positive it opens up, and if a is negative it opens down. And then also if a is bigger than 1, we're going to get something that's sort of narrow. And if a is less than 1, and of course still a positive number, we're going to get something that's sort of wide compared to the x squared function. Here, if a is of course negative 1, it's going to open down. So this is all review from the previous section. We also had if you're adding or subtracting a number outside the x squared function. So if I had something like x squared plus 2, the parabola would be shifted up 2 units. And if I had something like x squared minus 2 for my parabola, it would be shifted down 2 units from the origin where the basic parabola begins. Then we have the plus or minus number inside the binomial. So if I had something like y equals x minus 2 squared, it would actually be right 2 units that the parabola shifted. And if I had something like x plus 2 squared, it would actually be shifted left 2 units. So basically quick sketches we could get if we just remember these forms. So again, quick sketches, ax squared would either give me like sort of a narrow parabola if a was, for example, 2 bigger than 1, and sort of a wide parabola if a was less than 1. Negative x squared would just open the parabola down. X squared plus a number would shift it up 2 units in blue, and x squared minus a number, or in this case 2, would shift it down 2 units in red. X minus 2 quantity squared in blue would shift your parabola from the origin 2 steps to the right, and x plus 2 quantity squared would shift your parabola 2 units to the left in red. So this was a quick review of the cases we encountered. So we're going to combine these ideas and get the vertex form of a parabola. We know what the quadratic form looks like. Now we want to know what the vertex form looks like. So the vertex form of a parabola sort of looks like it has a binomial squared. It's a little different than the quadratic form up here. The a still plays the same role of positive opening up, negative opening down, smaller than 1 kind of wide, bigger than 1 kind of narrow. And then the h and k you pull out from these two ideas, and that'll give you the vertex of the parabola. So it's really nice because you can pull out the vertex quickly. So let's look at an example. It says give the vertex of the parabola. In part A, all I have to do is go find my h that comes after the minus sign and my k that's at the end, and I've got the vertex to be 1, 3, and I'm done. Because it's already in vertex form, it matches this up. In part B, it's in quadratic form. It looks like this guy, so I need to put, I could either put it in this form, which is a lot more work, or just use the formula from before, negative b over 2a, with a, b, and c pulled out basically. I don't need the c, I just need the b. Negative 8 and also the a, times 2 over 2, and that's negative 8 over 4. So the x-coordinate of the vertex is negative 2. Then I go and I put it back in to get the y-coordinate. Notice that it is more work for me to get the vertex. So for part B, the vertex is going to be the negative 2 for the x-coordinate and the negative 11 for the y-coordinate. More work if it is in quadratic form, very little work if I have it in vertex form. Okay, let's look at the example. Give a quick sketch of the parabola. So if I'm giving a quick sketch, I know that this is a shift up. I know that the negative 1 is a shift down. And I know that the negative 2 opens the parabola down, and it's sort of, because there's a 2 involved, it's sort of narrower than your regular parabola. So I have my notes made, and I just need to give a quick sketch. It's shifted from the origin up 5 steps. 1, 2, 3, 4, 5. And it opens up. That's all I got to do. The next one, we have it opening down. And also it's shifted down 1 unit. So it opens down like that. But because it's shifted down 1 unit, I'm going to go to -1, and then I'm going to kind of make it skinnier than this one because of that 2, making the parabola narrower. So that would be a quick sketch. And I can pull off the vertex, no problem. The vertex here is 0, 5. Not that it asks for it, but I can get it. The vertex here is 0, -1, it looks like. Same directions, give a quick sketch for the parabola for part C and D. So for part C, since the +3 is on the inside, I know that's a left shift, and since it's a -1 on the inside, that's a right shift. And everything else is the same, it's just an opening up parabola. 1, 2, 3 goes to -3. From the origin, the parabola gets shifted 3 to the left, and I can see the vertex is -3, 0 in this case. For this guy, remember a -1 makes it go to the right, so parabola used to open at the origin up, but now it has shifted 1 unit to the right, so the vertex is 1, 0. Let's look at E. Remember this makes it go left 3, and this makes it go up 2. And also if I compare to the vertex form of a parabola, I can just pull out the vertex HK out of here. There's my number related to H, there's my number related to K. So the vertex is actually the opposite of what's inside, -3, because it has to come after the minus sign. So you can think of this guy as like a -3. That's why the vertex x coordinate is -3, because double negatives make a positive. And it's always the H that comes after the minus sign. And then the y coordinate is K. And we do know the leading coefficient here is 1, so we just go to the vertex, -3, 2, and we know it opens up. There's our quick sketch. Alright, let's see here. This is going to make it open down, and it's kind of going to be narrower because the 3, the factor of 3. This and this will give me the vertex right off the bat to be a 1 and a 5, it looks like, because the 1 is already after the minus sign, and then the 5. So I got my vertex to be 1, 5, and I know my parabola opens down sort of narrower, so I'm going to go to 1, 1, 2, 3, 4, 5, 1, 5, and my parabola opens down, and it's sort of narrower. So just a rough sketch. I'm not giving you specifics what the x-intercepts are. I'm not giving you specifics what the y-intercept is. Those we could find if it said give an accurate graph. X-intercepts, you would make the y 0. Y-intercepts, you would make the x 0, and then find accordingly. Let's look at another example. It says give the equation of the parabola in vertex form and then in quadratic form. So in vertex form, I'm going to need ax minus h squared plus k. And also for this problem, I'm going to say assume a is equal to plus or minus 1. So there's no narrow or wideness going on. It's just your basic parabola either opening up or down. So that one is already given to you. So here is the equation we start off with. I have to pull out the vertex, which is right here. The vertex coordinates are -1 and up 2. And then since this opens down, a must be -1. Again, why -1 out of the choices given? Because it's opening downwards. So plug the pieces back in the proper locations. Put it in here, and here, all the information you just found. So we're going to end up with y equals -1 for the a, x minus a -1 for the x coordinate, squared, plus a 2 for the y coordinate of the vertex. So y is equal to -x plus 1 ultimately squared plus 2. So there's the equation in vertex form. Now part B, it says give it in quadratic form, and that means I just have to simplify the vertex form. So in vertex form, I have x plus 1, and then remember it's a binomial squared, x plus 1 plus 2. So I'm going to go ahead and multiply that out. And that's going to simplify to x squared plus 1x plus another x plus 1. And then I made this bold because it's going to go and apply to everybody. And then the plus 2 is going to just carry down. So I'm going to end up with negative x squared minus, combine these two, that's going to give me 2x, so that's minus 2x, minus 1 plus 2, and that's going to be y equals negative x squared minus 2x plus 1. So here it is in quadratic form. So quadratic form is easy to get from the vertex form if you're able to multiply things out. Now this tells me, remember the last number in the quadratic form is always the y-intercept. This is reassuring because notice what the y-intercept is. The y-intercept is 1, just like this tells me. Okay, I'm supposed to graph this parabola showing the intercepts and the vertex. So I have to have an accurate graph, not just a quick sketch. Now remember this is in quadratic form. So I don't have the vertex right off the bat, but I do know that I have the y-intercept, because if I make x 0, the y-intercept is always going to be that last number, which is negative 3. So the y-intercept is 0, negative 3. Part B, I'm going to find the x-intercepts, which means make the y value 0. So here I make x 0, here I make y 0. Well, y is my f of x. If I make that guy 0, it looks like this should be factorable, and I get x minus 3x plus 1. So it pops out two solutions, negative 1 and 3. So there are my x-intercepts, two separate x-intercepts. C, I'm just going to go ahead and find the vertex as they asked me. And since it's in quadratic form, I'm going to use the formula negative b over 2a. So negative b is going to be negative and negative 2 because that's my b, and my a is a 1 over 2 times 1. So that's positive 2 over 2, which is a 1. Let's go put it into the function and find the y-coordinate of the vertex. And when I do that, it looks like I get negative 4. So the vertex is 1, negative 4. Now this should be sufficient info for me to get a pretty good graph. I have the y-intercept to be negative 3. There's my y-intercept. I have the 2x-intercept to be 3, 0, and negative 1, 0. I have the vertex to be 1 and down 4, 1, negative 4. And I also know that this parabola opens up because the leading coefficient a is positive. So from here, I'm just going to make my parabola go through those points and open up. So there's my parabola showing the intercepts, two x-intercepts, one y-intercept, and also the vertex clearly. Sometimes you may be asked when the graph is increasing and when the graph is decreasing. And you're just going to walk left to right on your graph and answer that question. So I'm decreasing until I get to the vertex x-coordinate 1. So all the way from the left, which is negative infinity, like all the x values on the left, they keep going to the left, is negative infinity, up until this x-coordinate of positive 1 actually, which is my vertex, it's decreasing. The graph. So it's decreasing, I'm going to put it here, from negative infinity to positive 1, the graph is decreasing, and then once I pass the vertex, the graph starts increasing. So from positive 1 all the way to infinity, the graph is increasing. So increase and decrease just simply says left to right, just walk through your graph up until your vertex, in this case you're decreasing. Always pull the x-coordinate of your vertex, and then from your vertex on you're going to be increasing. So increasing from 1 all the way to the right, and decreasing from negative infinity all the way to the left up to 1.